Okay, for this section, we need to review dividing exponents and multiplying fractions. In order to do this, we have to simplify the following problems. So looking at 1, remember our dividing exponents. We understand that when we look at x to the third divided by x to the fifth, that is actually saying that we are going to subtract those exponents. So remember on this one, sometimes the nice thing is just to draw a line and then figure out what goes where. I'm going to go ahead and look at those exponents right away because we were just talking about them. 3 minus 5 is actually x to the negative 2. So when we see that negative, we know that that x is going to be in the denominator with the power of 2. Another way of saying this, we could see, and some students can visually see this, that we have 3 x's on top, 5 on bottom, 3 go away, there's 2 left in the bottom. Okay, now let's go ahead and look at the 6 and the 4. What factors do they have in common? Well, this is 3 times 2. This is 2 times 2. We can cancel out 2's. So it looks like we're left with 3 in the numerator and 2 in the denominator. Okay, so that is simplified. Taking out all the common factors. Dividing means take out all of the common factors. What about multiplying fractions? How can we do this? Well, technically multiplying fractions means that we could actually rewrite this as 2 times 1 over 5 times 4. Because when we're multiplying numerators together and multiplying denominators together. When we do that, look what happens. We can go ahead and simplify these two pieces. 2 goes into 2 once, into 4 twice. So we're left with 1 times 1 and 5 times 2, which is 1/10. Another way that we have been taught many years ago is that we can cross cancel. Basically doing the same thing, but we're skipping the step right here. So right away we could see that 2 goes into 2 once, into 4 twice. We end up with 1 in the numerator and 2 in the denominator. So we're going to skip this step, understanding what we're doing. That cross canceling is basically combining the numerators and combining the denominators, and then just simplifying from there. Okay, how about dividing fractions? Well, we understand that when we're dividing fractions, we're actually multiplying by the reciprocal. So the first term stays the same. We change that division to multiplication, and then we flip the second fraction. Okay, from there, again, we're going to skip combining numerator and denominator. We are going to realize we can just cross cancel. 7's cancel into 1's. There is a 3 in each one of these. So if we can't see that, you can go ahead and rewrite this as 3 times 2. This is 3 times 5. And realize that our 3's cancel. So what's left over? We have a 2 times 1. In the numerator, we have a 1 times 5 in the denominator. So 3 concepts that we're going to be dealing with: how to simplify exponents, how to multiply fractions, and how to divide fractions. We're just happening to throw in some exponents in some different rational expressions. We call this rational because it's a ratio. We call it an expression because it has those variables as well as multiplying by numbers. Okay, so that is what a rational expression is. All right, well, let's go ahead and put those concepts together up here. We know that we can cross multiply. So I'm going to start with my constants first and my coefficients. I'm going to focus on this 3 and this 9. 3 goes into both of them. 3 goes into 3 once, into 9 3 times. Now I'm going to look at my 2 and 4. 2 goes into 2 once, into 4 twice. Last step, I'm going to have to look at these exponents. And again, I'm not going to do the subtraction anymore. I'm going to kind of think that there were 6 in the numerator, 4 in the denominator. These 4 will cancel out, which means that there is 2 left over in the numerator, because 6 minus 4 is a positive 2. Okay, it kind of looks like an ugly mess, but let's figure out what this is. 1 times x squared times 1. Looks like we're left with x squared in the numerator, 2 times the 3 in the denominator. And there it is. We simplified a rational expression dealing with ratios. Okay, let's go ahead and look at this one. We are dividing rational expressions. So with division, we know we keep the first term the same, and we are multiplying by the reciprocal of the second term. So we flip it. Now let's see what we just did. We have x's. I'm going to go ahead and draw a line because I know I'm dealing with some pretty crazy rational functions. I see that these x to the thirds cancel. I'm going to get rid of 3x's down here and realize I have x squared left over in the numerator. Okay, do we see that? I canceled out 3 of the x's with 2 left over in the denominator. I'm going to cancel out 2 of the y's with 6 left over in the denominator. So let's go ahead and combine this. I got rid of both terms on top. So what do I have up there? I have that understood 1. It's always up there. So I know that I do have a 1 in the numerator. I have a y to the 6th and an x squared in the denominator. So have we dealt with dividing exponents before? Yes. And we know how to deal with fractions. Now we're just taking those two concepts and putting them together in order to multiply and divide what are called rational expressions. Rational because we're dealing with ratios, expressions because we are dealing with constants and variables together. Okay, go ahead and get out the notes and vocab for this section. All right, our objective is to multiply and divide rational expressions. And it says to multiply fractions. We know we multiply the numerators and then multiply the denominators and then simplify from there. We are going to use that same method to multiply rational expressions. So we're going to jump right into example 1 because again, we did go over this in the intro. We will get to that factoring part in just a second with B. But let's go ahead and focus on A real quick. Again, there's a lot of different exponents that we're going to deal with. Why don't we start with that r? We have an r squared in the numerator and an r in the denominator. So it looks like I can get rid of an r from each one. I have an r left over in the numerator. Now I'm going to look at my x. No other x's. So I'm going to move on and look at that 3. Again, this is a constant, so I'm not subtracting. I'm saying that both the 3 and the 9 have a 3 in common. So 3 goes into 3 once, into 9 3 times. Now I'm going to look at my t's. I have 4 t's on top and 3 on bottom. So it looks like I can get rid of 3 t's for each of them. And I'm left with 1 t in the numerator. Okay, since I'm dealing with a rational expression, I'm going to go ahead and draw my line and I'm going to figure out what happens in the numerator versus what happens in the denominator. I have an r times the 1 times the t. So I have an rt in the numerator. I have a 3 times technically a 1 over here. So I have a 3 in the denominator. Okay, now let's look at B. A little bit different because all of a sudden we have some a squareds in there and we're not quite sure what to do with that because look at this, we don't really have much in common. One common mistake that students look at right here though is they say, oh, well, we have a 4 and we have a -8 here, so we can cancel those out. We have an a, we have a 2a. No, the only way that we simplify is because all of these are products. We can simplify products. Look at this. These are additions and subtractions. We can't simplify those. But what do we know about factoring, which is always going to come back and play? We can factor this into 2 binomial products and then see what happens. Okay, so this is the question of what times what gives us a -8. Added together gives us a +2. So this is a factor sum problem. We have a -8 and we have a +2. Well, hopefully getting really good with factors, we realize 4 and -2 give us -8, and that does give us a sum of 2. So how does that help us out? We are going to rewrite this, not changing its value, but we are going to factor it into x plus 4 and x minus 2. Does that help us out? Yep, because look at this. This is now considered a product. This is the product of x plus 4. Here's the product of x plus 4. They now officially cancel. Okay, now let's go ahead and look at an a and an a squared. That is a product, so they both have an a in common. There is an a left over in the denominator. Let's go ahead and draw our dividend. Nothing in the numerator, but we understand that there's a 1 up there. We have an a, and we have, whoops, I'm sorry, I always use x's. That's kind of my weakness. I always go back to x's. This should actually be a minus 2. We have an a and an a minus 2. Okay, technically, we could go ahead and distribute those through and say a squared minus 2a. Okay, so biggest mistake is wanting to go ahead and just go crazy and simplify those pieces. But again, we have to understand that we can simplify products, and those are not products. That is addition and subtraction. So using concepts that we've learned before to simplify rational expressions. Go ahead and try guided practice 1. Okay, and there they are. This one was a little bit different because we actually had x's in 3 different places. So I went ahead and simplified by canceling down, ended up with an x in the denominator, but then cross-canceled here, and actually ended up finally with 1x in the numerator, and then all the way down just to a 2 in the denominator. B and C both had to be factored in order to realize that product of x plus 3 could be canceled. Same thing here, we had a product of y minus 4 in both numerator and denominator, and then those y plus 5's canceled. Down here, when we get to y plus 1 over y, those y's do not cancel, because again, this is the operation of addition. That y is attached to a positive 1, that one is not, so this is your final answer. Okay, please realize the difference between something like y plus 1 and 4 times y. That is a product, this is addition. Okay, looks like we need some review on dimensional analysis. It says that when you multiply fractions that involve units of measure, again, you can divide by the units in the same way that you divide by variables. So we're cross-canceling those labels in order to convert them over to a different label. So you can convert units of measure within a system and between systems. So Ann Proctor won the 2007 World Water Ski Racing Championship race in her category when she finished the 88-kilometer course in 51.23 minutes. What was her average speed in miles per hour? So we are supposed to convert kilometers per minute into miles per hour. That is our goal, understanding our goal. So what do we know? We know she did 88 kilometers in 51.23 minutes. Okay, we know that we have to convert that kilometers into miles. And look, they help us out with a little hint here. So we are going to use their hint. Remember, we understand cross-canceling now. We want to cross-cancel kilometer, and we want to get that into miles. Okay, remember that we can only multiply by 1 in order that we don't mess up this value right here. So how do we keep this balanced? Well, we know 1 kilometer is 0.62 miles. So we canceled out our kilometers, which is what we wanted. We got to miles. Now let's focus on these minutes. How are we going to get those minutes into hours? So we have to set up one more fraction. And again, we want to cross cancel those minutes. And we want to get it into hours. Well, how many minutes are in an hour in order to keep this balanced? We know there are 60 minutes in 1 hour. So we did it. Let me see here. We got rid of our minutes. We are down to miles per hour. Now we just have to do a little bit of math. We're going to multiply our numerator straight across. So 88 times 62/100 times 60. And I got something really big. Which is 3273.6. And then again, we're going to divide that by 5123 times 1 times 1, which is 5123. Okay. And we get grand total of 63.9 miles per hour. So just dimensional analysis, trying to cross-cancel basically our units of measure in order to convert it to the same speed, just in a different unit of measure. All right, go ahead and try that with guided practice 2. Okay, same concept with the conversions, but having to convert now into feet per second. So I did have to change 2 conversions in there. I still dealt with my miles and kilometers, but then I had to go feet in miles. Once I got down to feet, then I wanted to convert those minutes over to seconds. So I was comparing a minute versus a second. Ended up with 93.72 100ths feet per second. Okay, so just reminding us how dimensional analysis works by cross-canceling those units of measure. Now let's go into dividing rational exponents. And again, we talked about this, that we understand when we are dividing fractions, we are multiplying by the reciprocal of the second term, second product. So when we look at example 3, before we even start looking at any of those numbers, we keep that first term, we multiply by the reciprocal of the second product. Now we can go ahead and start comparing. So I'm going to start with that 4, and I realize that 4 goes into 4 once, into 12, excuse me, 3 times. Now I'm going to look at that 25 and 15. I see that they have a 5 in common, so 25 goes into 5 times, into 15 3. And then I'm down to my n's. I realize they both have an n, so the n in the numerator cancels. I'm left with n squared in the denominator. Now that I have an ugly mess, I have to figure out what I have. I have a 1 times a 5 in the numerator. I have a 3 times a 3 times an n squared in the denominator. So after that one little step of multiplying by the reciprocal, it's actually the exact same as what we did with multiplication. Cross cancel, sometimes we can simplify straight down. All right, and there is guided practice 3 for you to give a try. Okay, 3a, pretty straightforward. Again, a lot of mess going on there, but understanding that we were left with the 3y, 2, and an x squared in the numerator. So that becomes a 6x squared y. X comes first because x comes first in the dictionary, basically. All over 1. So let's go ahead and simplify that just down to a 6x squared y. 3b was really tempted that we could do some canceling right here, but again, we're dividing, so we can't do that until we multiply by the reciprocal. Then look what happens. We can't cancel that 16 or the 12 and the 6. We can't simplify them. Same thing with that 5 and 25 because they are both denominators, both numerators. So only thing we could do is get rid of a couple a's and b's. We were left with 72ab over 125. Okay, so don't force a simplification if it's not there. Let's look at this stuff. Okay, again, we're still dividing. Now we're looking at a little higher level type of problem. Well, I have an x plus 3 that I'm dividing by. Anytime I don't have a fraction, I go ahead and write that over 1. Because I know dividing means I keep my first term of 2x plus 6 over x squared. And I know I'm multiplying by the reciprocal of that second term. So I'm multiplying by 1 over x plus 3. That might help me out just a little bit. And then I realize that I have some addition in here. So I can't do any canceling here unless I see if anything can factor. Well, it looks like I can distribute out a 2 in the numerator over here. So I'm going to rewrite that as 2 times x plus 3 all over x squared. I'm still multiplying that by 1 over x plus 3. Does that help me? Yep, it does, because look at this. Since this is a product, I can go ahead and cancel out that x plus 3. Looking at this, doesn't look like I can do anything else, so I'm going to go ahead and simplify, saying 2 times 1 is 2 in the numerator, and just an x squared in the denominator. Okay, so starting to look a little scary, but again, know what we know about fractions, realizing that these really are just kind of fractions on steroids, basically. We're going to leave that first term as a minus 2 over 4a plus 4. We are multiplying it by the reciprocal. So we have a plus 1 all over a plus 5. And then we realize we can't go crazy and start canceling all of these a's out because we have that addition and subtraction. Only thing we can do is if they have common products. So looks like I can't do anything except maybe this piece right here. So I'm going to rewrite a minus 2. I see that I can distribute out of 4 here, and I'm left with a plus 1. And I'm multiplying that by a plus 1 over a plus 5. So that did help a little bit because we do have the common product of a plus 1 there. Can't do anything else. And again, we cannot cancel out these a's because 1 is attached to a negative 2, 1 is attached to a positive 5. Okay, those are expressions. So a minus 2 times 1 is a minus 2. And then we're left with 4 times a plus 5. Our final answer, because we do have to distribute that 4 through, is a minus 2 over distributive property 4a plus 20. Okay, don't be tempted to cancel that 2 out because we have to have a common factor on that a in order to do that. Final answer. So even though they look a little bit scary, we understand the concepts of dividing by a fraction. We also understand the concepts of factoring. So put them together and see what you get. Go ahead and try guided practice 4. Okay, one interesting thing about 4a is we ended up with a 4 on the top and then a 2 and a 2 in the numerator. So all 3 of those actually cancel out. We were left with d minus 4 and d minus 3 after doing a little bit of factoring. Okay, only thing we could distribute out over here was this 3b plus 12, which did cancel out a b plus 4. And then distributing that 3 through the numerator, we ended up with b plus 1 over 9b plus 6 as our simplified quotient. Okay, sometimes we must factor a quadratic expression before we can simplify a quotient of rational expressions. So looking at this, again, we understand how to factor. We just have to go ahead and use our clues about dividing by a fraction, and then we can factor and do some canceling. So step number 1, I'm going to rewrite as a product. So y squared minus 10y plus 16. I know I'm multiplying by the reciprocal. Step 1 done. Step 2, I'm going to factor as much as I can. I cannot factor y minus 3. However, I can probably factor this denominator, so let's try it out. What times what gives us a positive 16 added together a negative 10? Okay, well, a negative 2 and a negative 8 multiplied together give me 16, added together give me 10. So factoring, always going to come back. So denominator factored, can't factor y minus 8. This is one of those special factors. They're both perfect squares. We are subtracting them, so this is a difference of squares. So that means that we are going to have 2 binomials, one positive, one negative. We're going to square root y squared, which gives us y, square root 9, and that gives us 3. So now that we have it set up, we're going to do the fun part. We're going to start chopping. So it looks like I have a y minus 8 and a y minus 8 product that I can cancel out. We have a y minus 3 and a y minus 3 product we can cancel out. What are we left over with in the numerator? Nothing but a 1. So final answer, we have a 1 in the numerator. We have a y minus 2 and a y plus 3 in the denominator. And this is where it gets kind of tricky because sometimes this is the answer. That's what they want you to do. Other times they want you to actually FOIL that out. So I have 1 over y squared. 3y minus 2y is a positive y. And then a 3 times a negative 2 is a minus 6. So again, depending on the question, on the author of whoever put it together, either one of those could be your answer. All right, last 2 guided practice. Go ahead and give them a shot. Okay, and there they are. And I did leave them factored without foiling them together because that gets to be kind of ugly if we did. Looking at 5b, might be tempted to maybe try to simplify that 2, 4, and 12, but again, since these are additions, this is actually the product of these two binomials. We can only have binomials that are in common in order to simplify them down. Okay, so a little bit of review on factoring, a lot of review on having to deal with fractions and what it means to cross cancel or to simplify numerator and denominator. Okay, you are ready for the assignment for this section.